Good afternoon, everyone. My name is Dr. David Pugh. I'm a staff scientist at the KAUST Visualization Core Laboratory, as well as a certified instructor with software and data carpentry. So software and data carpentry are two global nonprofits devoted to teaching core or foundational scientific computing and data science and data analysis skills to students and faculty and research scientists, both in academia or scientists in industry. And so today we're going to pick up with the third workshop in the KAUST Visualization Core Labs Introduction to Data Science workshop series, which is on an introduction to Python for data science. So today we are going to be using teaching materials provided by or developed by the software carpentry community. And we are going to be using compute resources that have been provided by both my colleagues at the IT Research Computing group here at KAUST, and also the BinderHub Federation. So thank you to both of those organizations. Without you, I would not be able to provide today's workshop to such a large group. Looks like nearly 100 people at the moment. It just would not be feasible. So thank you very much for providing the computing resources, and to Software Carpentry for providing the teaching materials. So I'm going to go ahead and share my screen so we can dive right in, because we have quite a lot of material to cover today. Okay, so as has been the custom, the past few weeks, I'm going to be going with kind of a split screen approach. So I'll have today's lecture materials up on the left-hand side. Then on the right-hand side, I will have typically the Jupyter Lab instance that I'm using for the hands-on portion and the live demonstration and exercises and things like this. So just to kind of quickly cover go over what we're going to cover through the course of today. So there is more material here than I will be able to cover in today's 4-hour workshop. So typically this is a full day's worth of material, like 8 hours worth of material. So I'm not going to be able to cover all of it today. So what I'm going to do instead is skip around a bit. So I'm going to kind of cover bits and pieces that I think are the most critical, and leave certain lessons basically for you to kind of go over and dive a little bit more into the details on your own time. So just at a glance, what I suspect that we will cover is episodes 1 and 2. We will skip episode 3 and focus on 6, 7, and 8, which are on Pandas and reading data into data frames. And then we will try to dive into for loops, conditionals, and looping over data sets. And then the rest I will probably leave as kind of exercises for you. Okay, so let's just dive right in. So episode 1, running and quitting. So the big question when you're just getting started with Python is how can I run Python programs? So we're going to talk a little bit today, or a little bit in this episode, is on Jupyter Lab. So I'm going to show you the basics of Jupyter Lab and help you kind of be able to navigate your way around opening different types of files, different types of terminals, different types of notebooks within Jupyter Lab. And then we'll be using primarily Jupyter Notebooks as our interface today. Okay, so the first part of this episode walks you through getting started with Jupyter Lab. So Jupyter Lab is the web-based interface provided by the Jupyter project. So the Jupyter project has been evolving for quite a long time now. It started back with something called the IPython console, which we'll talk a little bit about in more detail in a few minutes, which was basically just an improved console experience for Python. And then it morphed into notebooks. And so some of you might already be familiar with Jupyter Notebooks or have encountered them or maybe even used them a little bit yourself. And then that has since evolved into Jupyter Lab, which is more kind of all-encompassing development environment for Python. And this is where all of the development is working now, or is going on now, is with the Jupyter Lab interface. Just seeing a couple questions in chat. Okay. So just a few questions in the chat. So no, there is no certificate for attendance. And the recording of this session will be made available via YouTube, and the link will be sent out together with the feedback form probably tomorrow, once I have the recording posted. Okay. So some of the setup with Jupyter Lab, we don't need to cover because it's already been done for us and provided in this cloud instance. So some of the details involving setting up a local install of Python that includes Jupyter Lab and other things, like we don't need to go into that today. Those of you who joined last week with for the Conda training already know a little bit about how to create Conda environments and install Jupyter and Jupyter Notebooks and Jupyter Lab inside of a Conda environment, which is what we have, which is what I have done to set up this this computing instance. There's a link here to the setup instructions for these Python lessons, and if you want to get a local install up and running yourself, you can kind of read through here and understand how to install Python and Jupyter Lab and things like that on your local computer. But I'm not going to cover that today. Okay, so normally when you start Jupyter Lab, you will start it with a local install. You'll start it from a terminal. So you'll open up a terminal and you'll type Jupyter Lab and hit enter, and that will launch the Jupyter server in your browser. Or that will launch the Jupyter server and then open the front end client in your browser. We don't need to do that because when we click these links, that's all done for us by BinderHub. But these are instructions to kind of help you if you are doing a local install. So let's just jump down to the Jupyter Lab interface itself. Okay. So there are Jupyter Lab has many features, and I'm only going to kind of scratch the surface today, and then we'll do a little bit more when we talk about SQL in 2 weeks' time. But just to familiarize yourself with the basic mechanics, so the basic interface for Jupyter Lab consists of the menu bar, which is this bar right here across the top where we have file and edit and view, run, kernel, git, all these other things. So this is where you can use your mouse to kind of access many menu items. So you can use the menu bar to launch new notebooks or terminals or text files, things like this. And you'll see some of these are grayed out. These are options that aren't available given the current state of Jupyter Lab, like saving. So we don't have a notebook or a file or anything open to save. So those are grayed out, things like this. You can also create new notebooks, consoles, or terminals or things just by clicking these little icons here in what is called the main workspace. And that's mostly what we'll be doing today. So the left sidebar is this area here. And by default, or the first thing that is displayed in the left sidebar is the contents of the current directory in which you launched your Jupyter server. So for us, what is displayed here is the files that are contained in this GitHub repository, because when we launched this GitHub repository on top of BinderHub and exposed the Jupyter Lab server, we launch that server from within this directory. So that's why the contents that we see here in the GitHub repo are the same contents that we see here. If you were doing this on your local computer, what you would see here would be the contents of the directory where you typed the JupyterLab command and hit enter. We can toggle this left or this file browser by clicking, turning this on and off. So that just gives us more space. So sometimes I'll have this open, I'll do some navigation. Most of the time I'll just close it just to get extra space in the main work area for demonstration purposes. There's other things in the left sidebar. So if you install JupyterLab extensions, which add additional functionality to JupyterLab, many of them will show up in this left sidebar. So there's a Git extension for using Git and GitHub from within JupyterLab. We'll talk about that in next week's tutorial. And then there are some other extensions that I've installed here, one for a tool called Dask, which we won't cover in this introduction to data science, but we might cover in future more advanced trainings and things like that. JupyterLab is one of the reasons it's very popular is that it's very extensible and easy to write additional or extensions that will provide extra behavior for JupyterLab. And there's a whole ecosystem of packages or extensions rather that help add additional features to JupyterLab. So it's a thriving ecosystem. Okay, so I see some of you might be having trouble accessing JupyterLab, that there are too many users. So what I would suggest is that if you're from KAUST and you're encountering this issue, then try the public JupyterLab. And if you're outside of KAUST and the public JupyterLab has too many users, then sorry, but you might have to wait until inevitably somebody will bow out of the workshop a bit early, and you might be able to join. Or these computing instances will always be available. So if you can't get access to a computing instance right now, you can always watch the recording of this workshop and go along, say tomorrow, and go through everything on your own. The compute instances will still be there. You can still use them even after this workshop is done. So, but apologies if we have hit that that bound. Okay. So the main work area. So the main work area is this area here, and it usually consists of a launcher, which is basically just a page where you can click these different icons to launch notebooks or consoles or terminal windows or text files of various flavors, things like this. And as you'll see, when you launch many different files, you'll have many different tabs, just like a browser across the top, and the currently active tab will be highlighted with blue. So here we only have one tab open, and you can see that has this blue highlight at the top. Okay. So what I would like to do now is to go ahead and create a Python script. So we can do this by simply clicking the Python file. So if you go ahead and click on the Python file, so this will create a untitled.py. So a Python script with a generic name. And if you go back and you click on the file browser again, you'll see that this file was created in our current working directory. So here we have this untitled.py was created just a few seconds ago in our current directory. If you wanted to create a file in a different location, you could navigate through the browser to that location and then create the file there. So for example, I could navigate into Introduction to Python, and into, say, the source directory, which is where I would normally create Python scripts. And then here, I could do either file, new Python file, or I could click this blue button here to get a new launcher. And now I can click these buttons again, but notice how at the top, we now have a path, introduction to Python /source. So when we see a path at the top of the launcher, we know that any notebooks or consoles that we open or files that we create will be created within that directory. So now if I click on Python file, I get another Python script, untitled1.py, created in that same directory. So there are many ways to create new Python scripts. You can also create them in the lecture notes. They show you how to create a new text file and then resave it as a Python script by changing the file extension. But a more recent version of JupyterLab that was released within the past few months, I think, just now includes when you have this click to get this launcher window, there's now just a button that does that automatically for you. So there's no need to do the multiple steps. And again, note, like when you go through and you click on the tabs, you can see how the blue tab indicating that the current tab kind of follows you as you go through. Okay. Okay. So let's go ahead and close, just go ahead and close these for now. And I'll navigate back to Introduction to Python. So what about a notebook? So again, Jupyter notebooks are very popular and probably one of the most widely used kind of Python interfaces, particularly in data science, machine learning, and scientific computing, because they allow you to weave text, images, videos together with code. And we're going to be doing that a lot over the course of today. So for example, if we wanted to create a new notebook, we can just create, we can use these buttons to create a new notebook. So I like to keep, when I organize my Python projects, I'll often have a source directory where I will put Python scripts, and then a separate notebooks directory where I will put notebooks. And so if I click on the notebooks directory, so we have Introduction to Python /notebooks here as our working directory. And we click on Python 3, and this will give us a Python 3 notebook. So notebooks are stored in a file format that's called JSON, which is short for JavaScript Object Notation. Like a web page, so it looks, the format of the data that's saved in the notebook file, you can open it and look at it, but it's really meant to be, it's written in a particular format so that it can be displayed in a web browser. So that's the idea. Okay. So we have a notebook here. So let's think about what else we might want to do. So typically, you might have many tabs open at the same time when you're working on a project. So for example, you might have a notebook open, maybe you have a script open, we can open a new launcher and then say, okay, well, maybe we'll have a terminal window open. What you can do in your main work area when you have these multiple tabs open is you can actually drag and drop them around. So for example, if I want to have my terminal window be here, and then I can put maybe a script over here, and then I can rearrange these. So for example, I can move this terminal down here. So I just have just a little bit of a terminal going on here. And then maybe I have a setup like this. And so I might use my notebook to prototype some code. So for example, I might try to import a library. So I'll import a library called NumPy as NP, and maybe import another library called Pandas as PD, and then I will run this code. And we'll talk in more details about running this code in a minute, but when you run code in a notebook, you use Shift and Enter. So hold down Shift and hit Enter to run the code. And once I know that this code is working, then maybe I say, okay, well, I'm done prototyping this code, and then I will move it over to my my Python script, save it in my Python script. And so now I have a Python script, and then down here in the terminal, maybe I might want to run this Python script. And so then we would run a Python script maybe in a terminal. We'll see some examples of how to do that later. So what I would like you to do now is just take a couple of minutes and practice opening different types of files and just dragging and dropping the tabs around and try to organize your main work area, such that you just get some practice with opening files and things like that, and get a feel for what your main work area might look like, for example. Okay. So I'll stop sharing my screen for a minute. So there's a question in the chat. Can you repeat how to open the terminal? Sure. So let me just first set a timer so everyone can kind of get some extra practice on that exercise. And I will share my screen again. Okay. So if you want to open a terminal, so I'll go down here, I'll just close this, I'll close this terminal for now. And there's a couple of ways that you can open the terminal. So you can always go to File, New, New Terminal. Yep. And then you can maneuver around your terminal however you wish. So that's one way to do it. Alternatively, you can always do a new launcher. So if I click a new launcher, then I can go and find the terminal here, and I can open another terminal. And again, I could move this around however I want. So now I have maybe two terminals open. I mean, I generally wouldn't have two terminals open at the same time, but you obviously can have as many open as you wish. Okay. Any other questions? So if you're just joining late, so here's the link to the teaching materials with the current episode that we're going through. So question in the in chat. So is JupyterLab for Python equivalent to RStudio for R? So yes. So they're not. So okay. So they're equivalent in that they're trying to serve like the same purposes, like an integrated development environment for Python users. You can actually use JupyterLab for not just Python, but you can also use it for for R or C++ or Fortran or Scala or any of the other languages that support the Jupyter kernel spec, which is a little bit more detailed than we're going to go in this particular training. But if you, programming languages can write an implementation of the Jupyter kernel for that language, and then you can write, once you implement that kernel, then you can have notebooks and consoles and things like that for that language. So there's everything from Haskell to Java, C++, Fortran, all have kernels that allow you to run notebooks and consoles and things for that language within Jupyter. And we're going to see some examples of this in 2 weeks' time when we run SQL notebooks and SQL consoles, where we'll be using an implementation of the Jupyter kernel for the SQL programming language to write SQL queries within Jupyter Lab. You do not need Jupyter in order to use Python. You can use Python has its own terminal, for example, or its own console environment. So if we have a terminal open here, if you were to type which Python, you could see that the Python that we're using is the Python for the Conda environment for the BinderHub instance. So if you were to type Python and hit enter, you would be dropped into the Python interpreter. So this was the original Python user interface way back in the day. And you could type Python commands like importing a library. And you could do calculator commands and this kind of thing. But if you made a typo, then there wasn't a good way to go back and edit it. And there's no graphics or text highlighting or anything like that. So typically you don't just use the basic Python interpreter, but you can totally use Python, without Jupyter at all. And if we want to exit out of the Python interpreter, I think we type quit with open and close parentheses. But yeah, Jupyter is a very nice to have, but not necessary. Can you share your screen? Yes, of course, I can share my screen. Sorry about that. Share. Okay, let's clear this out. So if you had a terminal, so the question was, do you need Jupyter to use Python? And the answer is absolutely not. If you have Python, almost every computer has Python installed on it. In some way, shape, or form. Usually an operating system will need Python to do things. So if you opened up a terminal on your Mac or your Linux or a command prompt on Windows and then typed Python and hit enter, you'd be dropped into your Python interpreter. And this was the original Python interpreter that was the user interface for Python way back in the day. And you can type things like, you can import packages. So here I'm just typing these commands that I had typed above in the notebook. You could do calculator things, that kind of stuff. But it's not the most user-friendly environment. There's no support for multi-line editing. So if I did something like this, then I have to go back and toggle through here and then make the change, and it's a little clunky. There's no support for multi-line editing, so you can't have here I have two lines of command in one text box, which I can execute as a block. You can't really do that very well here. So this is not, Jupyter is a much nicer user interface for Python than the basic Python environment, or the basic Python shell, I guess. So we won't spend really any time with the Python shell today. Okay. So I think now everybody's had plenty of time to kind of go over and play around a little bit with JupyterLab. So let's head back to notebooks. So today we're going to spend almost all of our time in notebooks. So I'm going to go ahead and get rid of the terminal. I'm going to get rid of the Python scripts, and I'm going to toggle the file browser off so we have as much room as possible in this notebook. Okay. So let's talk about Jupyter Notebooks. So notebooks allow you to mix together code and text. So today we'll be building up a notebook that has code cells, like this cell here that has actual Python code in it that we can execute and expect to get results from. And then we'll create some text cells where we'll use a language called Markdown to write some nicely formatted text that kind of documents what our code does along the way. And you'll get an idea of how these notebooks can be used to kind of mix together code and text cells. Sorry, I missed a couple of questions in the chat. So one question, what purpose of the different types of windows have you opened? So the notebook is typically, so this is a good question. So a notebook, which is what we're going to use today, is typically for prototyping work. I use notebooks as kind of like my lab notebooks, but for code. So all of my data analysis projects all start with notebooks. And once I get to the point where I am happy that my code is working, it's doing what I think it should do. If I want to then use that code and run it, say, on a remote cluster somewhere on a much larger data set, then I will refactor my notebook and create a script. So a script, an example of a script would be like a .py file. So in this .py file would be the relevant pieces of the notebook that are required to perform the analysis, but in one single file that I could execute without having to independently of Jupyter on a remote server somewhere. So that's generally how the difference between like the notebooks and the Python scripts. Now everybody has their own kind of preferences in terms of what they would prefer to use, whether you like scripts or notebooks. Some people don't like notebooks at all. They prefer to write everything in scripts. Totally fine. Some people just like to use notebooks and never write Python scripts. That's also fine. I tend to find this middle ground where I do a lot of prototyping in notebooks. I also use notebooks to share my work with others, because you can mix and match text cells and code cells and images and video and things like that. It makes it a really handy way to share your work with others. So that's kind of the difference. And there was also a question about what's the difference between Jupyter and Google Colab. So Google Colab took the open source version of Jupyter Notebook and added some proprietary extensions and things on top, and then launched it as Google Colab about a few years ago. So there's not a lot of difference at all in terms of like the key ideas of Jupyter Lab and Jupyter Notebooks and what they're supposed to be used for. It's just that Google Colab has used them to provide an interface into Google Cloud Platform in a way that people are very comfortable with, because Jupyter Notebooks are so widely used. And they've added a few extra features that are relevant for Google Cloud users. And they've added some really cool features that they have unfortunately kept proprietary. So there's another question. So what distinguishes Jupyter Lab from MATLAB? So there is Okay, so the way I would look at this is like, so when I started, this is more of a question of like what differentiates, say, Python from MATLAB. So Jupyter Lab is a nice user interface for the Python programming language, as well as other programming languages, but we're going to use it mostly for Python, and mimics maybe some of the UI features that you would see in MATLAB or Mathematica or some of these other proprietary programs. The way to think about, or the way I think about MATLAB versus Python, and again, this is only my, my personal subjective opinion. I switched over from MATLAB to Python when I was in graduate school. Our department had a site license for MATLAB, but you could only use it on department computers, and I didn't have access to MATLAB on my laptop. And so instead of getting a free version of MATLAB or using Octave, which is an open source MATLAB clone, I just decided to invest my time in learning Python, which at the time offered everything that I needed to do in MATLAB in terms of, with packages like NumPy and SciPy and things like that, and seemed to be the growing ecosystem, over 10 years ago now when I first started grad school. And I think that that's largely continued till today. I think for me, the reason that I use Python in my work is that's because that's what everyone else is using in the data science and machine learning ecosystem. So there's a huge amount of development effort in creating packages for doing data science, scientific computing in Python relative to other options, MATLAB, Mathematica, things like this. Also, from a pragmatic standpoint, Python is an extremely marketable job skill. Whether you continue in academia and want to do computational science or work in academia, or if you want to go and leave academia and get a job in a commercial enterprise somewhere. So Python is a very marketable job skill, whereas my personal experience is that MATLAB is much more niche and focused heavily on a few engineering disciplines. So that's my subjective opinion on the Python JupyterLab MATLAB stance. Good questions though. Okay, so back to notebooks. So notebooks have command modes and edit modes. So command mode is when, so let's start with edit mode. So edit mode is the mode that we're most often in. So we're in edit mode when we have this green, or this blue box here. Our boxes, our cell is outlined in blue, and we're editing, we're typing commands. So maybe we're typing 2 + 2, and then we're evaluating code with Shift and Enter. And so that gives us 4, of course. If we want to go to command mode, you can press Escape, and notice that the blue box that was around the cell is now gone. So now we're in command mode. And in command mode, we can use keyboard shortcuts to do things like, there is a command A, oh, sorry, escape. Sorry, there we go. So let me just type something. So this is a cell. So I'm in edit mode now, and I'm editing the contents of this cell. And then I can evaluate the contents of the cell by hitting Shift and Enter. Now, if I go back to the cell, I can hit Escape to go from edit mode to command mode. And then in command mode, I can use keyboard shortcuts. Like I can press the letter A, and that creates a new cell above the old cell. So now I'm in edit mode again. And so this is a cell I created above the original cell. And if I hit escape to go into command mode. If I hit B, that will create a new cell below. So created below the original cell. So here's a cell that I want to delete. So if I have a cell that I want to delete, I can hit escape to go to the command mode and then hit X, which will delete the cell. And then if I hit escape to make sure I'm in command mode and I hit Z, then, or Z, then that undoes the previous command. So that, in this case, it undeleted the cell that I had deleted. So in these commands are documented over here in the lecture notes. There's quite a few more keyboard shortcuts. So in the help menu, you can find a whole bunch of help references for different libraries even, as well as references for Jupyter and JupyterLab, things like that. And there's a whole bunch more keyboard shortcuts, but we're not going to go into them. Okay. So I'm going to hit escape to go to command mode and hit B to add a cell below. And so this cell, so we've been doing code up until now, we've been doing code cells. Even these cells here are technically code cells. I added this character, the hash symbol, which is what's used to create comments in Python. So code that isn't going to be code that will be ignored and not executed. So these are technically all code cells here. But we can also create text cells. And there are a few ways that you can create a text cell. One, you can just use your mouse and you can click on a cell. And you can come up here to where it says code. And you can select cell types. And you can select, say, Markdown. And now in this cell, I can type Markdown code, Markdown, which is a text markup language that allows you to do all sorts of stuff. And I'm going to show you some examples here. So this is a header in Markdown. And now when you hit Shift Enter and evaluate that, it renders this cell as Markdown. And if you double click on it, you can go back and edit it. So here is how to add a bullets lists. And you hit Shift and Enter to evaluate the cell, and then it renders it in Markdown. So you can go through and you can have these code cells and these Markdown cells and have almost like a self-documenting bit of code, or you can even write whole papers or books even in Jupyter Notebooks. There's a software called Jupyter Book, which allows you to take collections of Jupyter Notebooks and turn them into a book. There's software that allows you to take a Jupyter Notebook and convert it into a LaTeX typeset PDF, like you might submit to a journal. There's quite a lot of interesting infrastructure built up around JupyterLab and Jupyter Notebooks. Okay. So if you want to know, so the difference between command mode and edit mode. So anytime you click on a cell, you're going to be in edit mode. So just clicking on a cell is going to put you in edit mode. You'll see this blue box around the cell, and then you'll see a blinking cursor inside the cell. And in edit mode, if you hit Shift and Enter, then it will execute the code cell and return the result. So here you would get 4. Now, if you accidentally typed code into a text cell, so for example, suppose I have this cell here, and I accidentally had turned it into a markdown cell, and then I did 2 + 2, and I hit Shift and Enter to execute that. So here I'm not getting a result, and I might be confused as to why that is the case. But if you click on the cell, you can look up here and you see that it's markdown. And if you go back and you change it to code, then it will go back to being code. And then if you evaluate a code cell, you'll get results. If you're ever in doubt about whether you're in edit mode or command mode, you're probably in edit mode. And if you want to hit escape, escape will always take you from edit mode into command mode. So you can just hit escape a few times and then check, and then you'll know that you're in command mode. Okay. So in Markdown, you can use bulleted lists, you can create numbered lists, you can do sub lists, you can do headings and subheadings. You can embed links. So if you wanted to embed a link, so I'll go in here and say, so this is the link to today's teaching materials. And then the text that you want to include in the link, you put in square brackets, and then the link itself, you would put in inside of parentheses. And I'll just delete this part of the link. And then if I hit Shift and Enter, then I'll have a link. And if I click on the link, it will take me to that particular page. And if you double click again on the markdown cell, it will allow you to go in and edit the markdown cell. Right. So there are some exercises here. So let's take a few minutes and take a look at those exercises. They're mostly on markdown cells, and get some practice with just get some practice creating cells, code cells, and markdown cells, and do some simple mathematical exercises like calculator arithmetic and things like that. And then you can also ask questions if you want. So I'm going to just stop sharing for just a minute. The number turns orange with a dot. What does that mean? Now I need to share my screen again. Okay. So orange with a dot. So I bet, right, I bet like this. So orange with a dot. So this is actually a new feature in JupyterLab. It indicates that you have a cell that has been edited but not run. So previously, I had this cell that had 2 + 2, and then this result was 4 because I had executed the cell. But if I go in here and I make a change, then JupyterLab kind of tells me that, hey, you've made edits to this code cell, but you haven't rerun the code cell to generate a new result. So the result, the code in this cell might not produce this output anymore because you've changed it, which is true because now I've, instead of 2 + 2, now I've got 2 - 2. And if I execute this cell again, then I get the new answer, and then the orange bit goes away. And now when I click on it, it's blue again. So hopefully that answers the question. So it's a nice feature in that it lets you know when you have code that hasn't been executed yet. Okay, so take a few minutes. I'll set my timer to make sure that we're staying on task, and have a look through these exercises, and then let me know if you have any questions. Okay, so since nobody seems to have any questions, I'm just going to continue to demo a few things whilst giving you all some time to look at, work on some more exercises. So one of the nice things, particularly when you're doing scientific work, is the ability to render mathematical equations inside the notebook. So I'm going to go escape into command mode. I'm going to create a new cell above, and I'm going to make it a markdown cell. And then I'll just do so here's a subheader. So you can use LaTeX, which is a language for typesetting in general, but most often used to typeset documents that have lots of mathematical expressions or maths equations or formulae. And you can write LaTeX inside of markdown cells, and JupyterLab is smart enough to, when it parses the markdown cell, which just kind of like goes through and reads the markdown syntax, it can identify the little LaTeX blocks and then render them using a LaTeX renderer in the browser. So you can write mathematical expressions. So you can do things like e raised to the pi 1 to 0. And when you hit shift and enter to evaluate that cell, it renders this block in LaTeX, which is very nice. And I think that's the right. It's the right version of it. Somewhere in here. Yeah. Oh, +1. Shoot. I got it a little bit wrong. Of course, +1. And I will put formula. So there's a link. And if you want, if you want this math equation to be like centered, which I often do because I'm slightly pedantic about formatting and things, then you can just add 2 $signs, and then that will center align the math equation. So if you are an advanced LaTeX guru, then you can do all of your normal LaTeX stuff that you would do for formatting mathematical equations inside of these markdown cells, and they should just work in the way that you would expect them to work. So you can do align blocks and formula blocks and all kinds of things like that. If you want to do multi-line formulas and all that kind of stuff. So, okay. Right. So I think I've kind of covered, I went through this in quite a lot of detail because, it's just always good for you to know your way around before we start actually writing Python code. So hopefully, are there any other questions about JupyterLab or like just the basic mechanics of using JupyterLab? Because the rest of the day is going to I'm just going to do this stuff, and we're going to focus more on actually writing Python code. So could you mix languages like Python, R, and Bash in a single notebook? So yes, you can actually. So for example, there are a few ways to do this. The simplest way is to use something called cell magics. So cell magics are special commands within Jupyter that allow you to change the interpreter that's used in an individual cell to execute the code in that cell. So the simplest one would be something like bash. So if we do %% bash, then we can write code in this cell, and it will be executed as if you had written a bash code in a bash terminal. So if we did something simple like ls-l and evaluate that, then we get the results of what is written or what would be in the working directory of the notebook. So, so for example, if we did, so let me change this to pwd for print working directory. So we can see that this is in fact the directory that this notebook was created in. And then if we do the same again, we could do ls-l. We could see that, okay, these files in that directory, you could do multi-line things. So we could do, if you came to the bash course, we did for loops in bash. So you could do for I in, let's see. So for, let's just say file name in, or even better. So you could do for notebook in anything that matches the IPy notebook extension. Do, and then echo notebook. Done. So here, this is actually executing a for loop in bash, and it's just printing the, and I've made a mistake in here, $ notebook. So $ is from our bash workshop. You need to use $ to access the name of this notebook variable. And so this echo statement just prints the file name. So that's an example. You can also do, if in your software environment where Jupyter is running, you have files to support other programming languages, you could actually use like R magics or Haskell magics or SQL magics to write code with those programming languages in individual cells and execute the code and get results. Okay. So there's a question about subscripts and superscripts in Python. I'll answer that in a minute. We will, when we get to actually writing Python code. So this formula that I wrote here is written inside of a markdown cell using a markup language, or using a mathematical typesetting language called LaTeX. So you can read more about that in this last exercise here. It talks about LaTeX formatting and things like that, but it's not in Python. So we'll talk about Python in a minute. Okay, any other questions before we move on? So shift and enter doesn't work. So for those of you, so there are at least 2 of you for whom shift enter doesn't work. So if you type in a cell that says code 2 + 2 and hit shift and enter, you get nothing. Okay. Try creating a new notebook. Maybe something has gone wrong. In the top right-hand corner, does it say Python 3? So this is what I was suspecting. So if for some reason your kernel was disconnected, which shouldn't happen, but maybe it could happen, it should say Python 3 up here in the top right corner. And if it says kernel disconnected, if you just click on that and select Python 3, then you should be working again. So here, if you click on this and then you select Python 3, then it should be working again. Cool. Okay, good. So that can happen. Normally that happens if there's some kind of just like minor connection issue or something like that, or if your notebook crashes, then you'll have to reconnect the kernel. So should it always be in a kernel? So yes. So I kind of glossed over this detail because it's a bit technical, but the notebook itself is just like a nice visual representation of the computation that you're doing. What happens when you type code in a notebook cell and hit Shift and Enter, then the notebook takes that code, kind of puts it in a little message, and sends it to the kernel. And the kernel is what's running in the background on either a remote server or on your laptop or workstation. And the kernel receives this message, it opens it up, it reads the code that's written there, and then it executes the code on your computer. So if the notebook isn't connected to a kernel, then the notebook isn't going to work because it doesn't have anything to do the computation, which is why you were hitting Shift Enter and you were getting no results. So you can work in the terminal directly, but then you don't get all the extra. Well, I would, if you think it's better to work in the terminal directly, I would encourage you to test that hypothesis by working directly in the terminal with Python, and then see if you prefer that to working in a notebook or in a different user environment. Typically, you don't get disconnected from the kernel very often. Okay, so moving on to the next episode, variables and assignment. Okay, so in this episode, we're going to talk about storing data in programs, and we're going to just write some simple Python assignment statements. So I'm going to come down here, I'm going to hit Escape and A to create a markdown cell, and I'm just going to call this variables and assignment. And this is a code cell. So I am going to change it to a markdown cell. Okay. So the equals operator is what's used to assign a value to a variable. So we could take a value like 42 and assign it to a variable, which usually has some English language name called age. And then if we hit enter, we can do another assignment in the same code cell. So we can create a variable called first name and assign the value of Ahmed to it. And if we hit shift and enter, then these assignment statements are executed and their values, 42 and Ahmed respectively, are assigned to the variables age and first name. And then once that code has been executed, we can reference these variables in other cells. So if we type age and hit shift and enter, we'll get the value 42. There's some conventions with variable names. So you can only use letters, digits, and an underscore. So underscores are typically used to separate multiple words in the same variable name. So like first name, for example, first underscore name. Variable names are case sensitive. All these different capitalization patterns of age are 3 different variables. Typically, variables are all lowercase letters. So all the variables that I write will use only lowercase letters, digits and underscores. Variable names, it's usually not a good idea to start variable names with an underscore because that pattern has a special meaning within Python. So we don't we're not going to use leading underscores until we understand kind of that special naming convention. When you're in a notebook, or you can use the print function to display values. So we can use the print function, and then we can do first name, comma, is, comma, age, comma, years old. And then when I hit shift and enter, then that code is executed. And the print function basically concatenates together all of the values that you put in here, and adds a space between them by default. So that's why you get the spaces added between these things. And notice that if I'm passing here some values, is and years old, as well as some variables, first name and age. So if there's a variable passed, Python will substitute the value associated with that variable before displaying the result. Now, when you're in a notebook, you don't necessarily have to use the print statement to display values. You can just write the name of the variable and evaluate that, and it will display its value. However, when you're writing Python scripts, you need to use the print statement in order to display values. So I typically, anything that I know that I definitely want to display, I'll just put a print statement around it and won't rely on the notebook to just display it for me. So variables need to be created before they're used. So for example, if I tried to do something like last name and evaluate that, I'll get this type of error. And so this is our first error that we've seen in Python. You will get used to them. But this is what an error typically looks like. So it will have the type of error, in this case, a name error. It will have hopefully some helpful information about what that error is, and then some indication of the context in the code of where this error occurred. In this case, there's only a single line, and it points to that line and said this variable is not defined. That means that there was no value associated with it already. So we would need to go back and assign some value to that variable, like we did up here, in order to get rid of this error. Okay. And we've already seen how variables kind of can persist between cells. And so the print statement, so here the commas, so this is a print, sorry, this function print. Commas, when we evaluate or when we call Python functions, commas are used to separate multiple arguments to a function. So here the commas are what separate these arguments that are passed into the function. So the commas are not printed here in the result. And we will talk about, there's another question in the chat about how to create vectors, matrices, and arrays in Python. And the answer, also provided by somebody else in the chat, is with the NumPy library. And we're going to focus on Pandas later. Pandas uses NumPy under the hood. But since there's a question about it, I will go ahead and say NumPy. So the NumPy project is how you create n-dimensional arrays, which would include vectors and matrices as subtypes in Python. So NumPy, you should think of NumPy as the MATLAB clone for Python. It has actually many of the same functions in MATLAB with the same names and things like that. We're not going to be using NumPy directly, only indirectly via Pandas later. But if you're super interested in diving into array computing in Python, then NumPy is the place to get started with that. Okay, so we can use variables in calculations. So if we wanted to take the variable age and add 3, that would give us 45. We could also reassign that variable to that new value. And now, if we ran this code, I'm getting an error. Fist name, indeed, fist name is not defined. First name is defined. Now notice here also that it had this red dotted line underneath. So that indicates that there's something wrong, that the Python or Jupyter has detected something wrong with this code before it even runs it. And indeed, there was something wrong with the code, and I had made a typo. So now this new value for age is what is accessed when it's replaced here. So we get 45 instead of 42. And if I ran this code again, and then ran this code again, go to 48, and so on and so forth. Okay. So Python, so next we're going to talk about indexing in Python. So let's suppose that we have Adam name and we give a string helium. Okay, and again, shift enter to execute the cell. Now, if we can do indexing in Python using square brackets. So you put square brackets and then a number, and in Python, indexing starts at 0. So this is different than some other programming languages. In particular, R is 1-based indexing. MATLAB might also be 1-based indexing, but Python is 0-based indexing. So if we put Adam 0, Adam name square brackets 0, then that selects out the 0th element in the string helium. You can do slicing, so you can select multiple. So we can do 0 up to, but not including the 3rd element. And so that gives us HEL, just as an example. You can also do negative indexing. So there's a handy way to get access to the last element in a sequence using negative indexing. And this also works for other elements. So you can go even further back. You can also do, you could go 3 from the end up to not including the last one. So there's quite complicated slicing that you can do to select out. And here we're doing a simple string, but the same will work for other data types like lists and things like that. And we're going to use the same kind of slicing syntax when we look at Pandas data frames in a little bit, and also we'll work on NumPy arrays as well. There's other built-in functions. So there's a built-in function called length, which you can use to look at the length of things. In this case, we'll look at the length of Adam name, so that gives us 6. So use meaningful variable names. So we've talked about creating variables. So you might be tempted to use variable names like X and Y and Z, or I and J and K. things that are like might be used in mathematical notation, I would discourage you from doing that, and try to use meaningful variable names. So one of the nice things about Python code is Python is a language that focuses on readability of code. And so when you see well-written Python code, it will read as English, or it will read very close to English in terms of an English explanation of what that code is doing. And we'll see some more examples of that, but it only works if you use meaningful variable names. Okay, so there are some exercises here. So I'd like you to take 5 minutes and have a look at these exercises. And I'll give you an opportunity to ask some questions. And maybe I'll do a couple exercises and then we'll move on to the next episode. So for the next 5 minutes, if you could just take a look at those exercises, get some practice with assigning values to variables and things like that. So if anybody is just joining late, so here's the link to the teaching episode that we're on. And here is a link to the GitHub repo. And then if you click one of the links in the top of the README file in the GitHub repository, you can get access to the computing resources that we're using for today. And the recording again will be made available on YouTube probably tomorrow once I've had a chance to edit it. Okay, so since there don't seem to be any questions, and I still want you to take a few more minutes to have some opportunity to work on those exercises. So I will be back. Oh, there's another question. So so Jupyter in the notebook, it should be auto completing like parentheses for you. Let me share screen. So it should auto-complete parentheses and brackets and things like that. So if I was to do something like print, then no, it doesn't. Why is it not doing that? This is a very interesting observation. It used to do auto completion of brackets and things. You know what? This is a good observation. So, So Jupyter Notebooks used to auto-complete like brackets and parentheses and things like that. I'm going to have to Google and find out why that doesn't seem to be working here. because it has always worked like that in the past. So that's a very interesting observation. So thank you for sharing that. I'm going to make a note of that and try to find out what is going on, because it should. I'm not quite sure why. Okay. So yes, so the question is, can you access these materials as PDF files? So yes, you can. Let me just quickly share my screen. So I believe if you scroll up to the top and you click on this like hamburger menu icon here, there should be an all-in-one page that I think you can get the whole lecture notes in one page, and then you can save that down as a PDF. Okay. Okay, so any last minute questions before we move on to the next episode? Nope. Okay, cool. So let's move on to the next episode. Okay, so the next episode is data type and type conversion. So I'm actually going to skip this episode and try to move on to some more advanced material. This episode just talks about at a lower level of detail than I think is probably necessary, the differences between ints, integers, floating points, and strings, and some of the basic data types in Python. So I think this information is probably a little bit too detailed for today. So I'm just going to go ahead and leave it to you as an exercise for the viewer. And also built-in functions and help. I want to get to the data analysis portions of this, so we'll not spend so much time on the simple built-in functions. If we encounter built-in functions later, I'll just talk about them as we go along. And also help. I will also talk to you about the different different ways to get help as I use them in the course of the tutorial today. So I don't think we need to go into that in too much detail. And we'll actually, now might be a good time to take a break, since we have been going for about an hour and a half. So let's take a short break, just a 5-minute break. Stretch your legs, maybe get a cup of tea, and we'll come back at 2:40, and then we will pick up with libraries, and then we'll go through libraries very quickly, and then we're going to dive right into doing data analysis and data frames. So we're going to take a 5-minute break, and I'm just going to go ahead and pause the recording. Okay, welcome back, everyone. So we're back on recording again. So let us jump right back in with libraries. Okay. So in this episode, we're going to talk about how to use software that other people have written, how to find out what that software does, and then we're just going to talk about how to use libraries basically in Python. So what is a library? So a library is a collection of files, sometimes called modules, that contain code that is used by other software programs. It could also contain data values, like numerical constants or things like that. So Python, when you install Python, it comes with a standard collection of libraries. These are part of the Python standard library. And there's a link here to the Python standard library for, I think, the most recent version of Python. And you can see that just glancing through here, there's quite a lot of libraries. So each of these individual links here goes to a different library that is part of the standard library. So there's things for text processing. There are different data types. There are numeric and mathematical modules. There's stuff for accessing files and directories. This pathlib is particularly useful. I use that a lot in my own work when I need to reference paths to data files or paths to output files, things like this. There is libraries for doing data compression and archiving. These are very useful. I use them sometimes to compress input data or compress output data. There are kind of some miscellaneous ones. There's argparse. So argparse I use a lot for creating command line options, so that when I run my machine learning jobs on IBEX, on our remote cluster computer here at Calst, I often want to modify these programs at the command line and as part of my job script. And you can use the library called argparse to learn how to do that for your Python scripts. That's very, very useful. There's things for parallelizing code and all kinds of stuff. Some of this other stuff is I use less frequently, but there is quite a lot in here. And okay. So in addition to the Python standard library, just like R has a whole ecosystem of user provided or user created packages, Python does as well. And these are all hosted on the Python package index. So on the Python package index, this is like, if you're familiar with R, R has something called CRAN, which is the repository of R libraries and packages. The Python package index is the same functionality, but for Python. So you can go through here and you can search for, different Python packages. And for example, if you wanted to search for PyTorch, so here is anything that has PyTorch in the name. And interestingly, so this PyTorch is not the PyTorch that one would expect to get, because that's right, on Python or on the Python package index, Torch is the package that, not PyTorch, even though the package is called PyTorch, Torch is the package. So this is the PyTorch, the Python package for doing deep learning that's most widely used here at Calst, and very widely used elsewhere around the world as well. As you can see from the GitHub statistics, it has a lot of users. Another one, so someone, NumPy, you can find NumPy in here. So here is NumPy. And you can search for other packages and things like that. But when we, the Python package index is kind of the one-stop shop for all of your Python packages. Where are we? Okay. If you want to use a library that is that has already been installed, you must import it before you can use it. So math is one of the modules in the Python standard library. So we can import math. And now that we've imported math, we can use the contents of the library. So for example, if we do math and hit dot and just wait a minute, what we'll see is basically, so this is some of the help menus for the different, for the contents of the math library. So we can use our arrow keys to kind of toggle through here and see these are different. So these are all various trigonometric functions, more trig functions. So here's an example of a mathematical constant. And other functions. So here's the exponential function, factorial function. And you can just kind of scroll through here and see all the different simple mathematical functions that we have available. So, and as you type, you can hit tab, and this will basically pull up anything that starts with a P as in this example. So I hit P, I hit tab, this pulls up anything in the math package that starts with a P. And so I was looking for math.py, and if we hit shift and enter to evaluate this, we see we get a floating point representation of the constant pi. And another example of help menu. So if you put a question mark after something and evaluate it, you will often get the help menu or the help information about that object or that variable or function or whatever it is. Okay. We can combine things together. So we could do math cosine of pi. We can get -1. We could do that Euler's formula from earlier. So we could do math dot exp, and then we had math dot pi, and then there should be some way in here to do a complex number. Is it J? Maybe you can't do complex arithmetic with this. So let's look at the documentation. I'm surprised that this isn't working, but I've never actually tried it in a class before. So e raised to the power of x. Okay, so from the documentation, the exponential function that is implemented in the math library requires a floating point number and not a complex number. So if I wanted to do a complex power, then I would need to use a different implementation of the exponential function. So maybe I would need to use numpy, the exponential function in numpy or something for that to work. So my teaching example turned out to not work as well as I'd hoped. That's okay. Sometimes those things don't pan out. So what was I going to do? Okay. Notice that we have to do math.cos and math.pi, or math.sine of math.pi, and things like this. So that's because anytime we want to use something from the math library, we need to prepend the math dot and then the thing from the library. If we wanted to use specific functions directly, we could import them. So we could do from math import cosine, sine, pi, and maybe tan for tangent. So once we've imported these things, then we could use them directly. So we could do something like the sine of pi divided by the cosine of pi, and then the tangent of pi. So if we import individual items from a library, we can use them directly. Otherwise, we could import the whole library and then use that library name to reference the things that we want to use. Now, a way to get around that. So first off, I don't really like importing individual elements from libraries. And the reason is that if you import something by an individual name and you have something that already has that name as a variable, then the thing that you import will overwrite the variable that you define. Okay. And so what I will typically not import individual items, but rather favor importing the library and using this notation, math dot. But that gets a bit cumbersome. So maybe a better way would be to import math and use something called an alias. So we import math as m. And then we can go through and we can do m dot cosine of m dot pi and reference things like that. Now, whenever you are you want to use a library, you need to import it every time. So, or you need to import it once. So you either need to import it once, usually, for a notebook that I was using in my own work, I would probably gather all my import statements at the top of the notebook and put them in one cell. Or in a script, all the import statements would come at the top of the script. And then when that script is run, or you execute the first cell in this notebook, it would import all the libraries that you were going to use for that notebook or in that script. But if you start a new script or a new notebook, then you're going to need to import the libraries again. Now, importing a library is not the same as installing a library. So you can't use a library in a script or notebook without importing it, and you can't import a library that you haven't already installed. So, for example, let me see if I can show you what an import error might look like. So if I try to import SymPy as, right, okay. So there is a library for doing symbolic mathematics in Python called SymPy. And it's a very powerful, super interesting library for doing symbolic mathematics, like that you might get in like Maple or Mathematica or things like that. But I didn't install it inside of the software environment that we use in this workshop series, because symbolic mathematics is not something that is really done in data science. So this is more for other branches of science and mathematics. So it's not installed, and this is the type of error that you will see if you're trying to import a package that has not been installed. So to fix this error, I would have to install the SymPy package, and then I could run this code. Import error. Okay. So there's a built-in function called help, which you can use to look up some documentation on the module. So this is basically just everything that we can find using the question mark, but accessing the individual functions. So for example, so here's cosine. Instead of printing out this huge document to the screen, which we can actually get rid of by clicking this little button over here to hide that long output. We could again do math.cosine and question mark and hit shift and enter, and it will just get the input for that or get the documentation for that individual function. You can also just hit tab and you'll get similar information. In this case, you're seeing not just cosine, but hyperbolic cosine as well. So anything that starts with COS. Okay, so we talked about importing specific items. We talked about import alias. Okay, so let's take 5 minutes and have a go at these exercises. And then there's a couple in here. This one in particular, this jigsaw puzzle, we'll do together because I think it illustrates some basic things about writing Python code. So I'm going to set a timer for 5 minutes. And please have a go at these exercises. And then we'll come back and do 1 or 2 of them together, and then we'll move on. And in the meantime, while you're working on exercises, I'll be happy to answer any questions that that you might have. And I know that that there might be a wider range of experience in using Python. So obviously, this workshop assumes nothing about your knowledge of Python and starts with very basic questions. But if you already have some experience in Python programming and you want to use this kind of downtime to ask me more advanced questions, then please do, and I'll do my best to answer them and provide links or whatever to more more advanced materials. Okay. So while you guys are sitting there, I just went ahead and launched the poll. And as I'm curious about the pacing, pacing is always a difficult thing to get right, and with such a large group and such a diverse background and experience levels, I would guess. So. Okay. So that little alarm sound says the 5 minutes are up on the exercise timer. So I'm going to share my screen. You can keep answering the poll. I'll leave it open. So I wanted to work through a couple of these exercises. So the first is locating the right module. So we have, just going to copy and paste this. So we have this string of letters, which looks like a random combination of A's, C's, T's, and G's, assigned to the variable bases. And we would want to select a random character from the string. So here's our basis string. And of course, we can select by an index using square brackets like we did earlier. But what we want is a way to randomly generate integers so that we can go through here and select different individual base at random. And so looking through the standard library, we want to try to find a library in the standard libraries that would work for us. So we might want to, here we go. So numeric and mathematical modules, there looks like there is a random library for generating pseudo-random numbers. So that's probably what we want. So if we go in here to our basis code and we import the random library, and I'll just comment that out. So we'll import the random library, and then let's see what we have in here. So random dot, and so we have all of these different functions in here for generating random numbers, it looks like, from different distributions. So what we want is like a random integer. So here looks like random integers. So rand int. And let's do 0 and the length of bases. And let's just execute this code. Okay, so if we execute this over and over, we can get different random integers, it looks like. So we could also assign this to random index. And then we could say bases random index. So now this looks like it's doing kind of what we want it to do. So we can go through here and we're executing this code differently, and we're getting a different random letter from the bases. Now, so if you weren't following along, so I kind of did already what this jigsaw puzzle, which basically rearranged some code in order to achieve the same result, but I did it a little bit differently. And so now I'm actually curious as to what the rand range so this rand range function fixes the problem with rand int, which includes the endpoint. So in Python, this is usually not what you want. And so what is the problem with this code? So it seems like we haven't seen a problem with this code yet. It doesn't seem to be generating any errors. So let's try to figure out what's going on here. So if we do the rand rand int from 0, let's try this. Okay, so here, remember when we talked about slicing and we said that slicing and indexing in Python goes from the start up to but not including the stop? Well, here rand int includes the stop. So this code 0 and 1 will give you randomly either 0 or 1, including 1. So if we execute this code a bunch of times, we get 0 and 1. But usually when we're doing when we're solving this problem, we only ever want the random numbers to be either 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10. So we would never want to get an 11. And if we look at the length of the basis variable, it is in fact 11. So this code might sometimes generate an 11, which would generate an error, because if we tried to do this, we would get an index out of range error, which means that there is, remember Python is 0 indexed, so there is no index 11 character in this string. There's only 0 through 10. So this code has a subtle bug, which might not be obvious, but maybe we could engineer if we did this. So here, this length basis will evaluate to 2 now, because I've forced this to just take the first 2 characters. And so this function now will generate sometimes 0, sometimes 1, and sometimes 2. But if it generates a 2, then it will generate this error. So it's less obvious, because as the number of bases gets longer, the likelihood of you generating an index equal to the length of bases also goes down. So it's a bit of a subtle bug, but if we can correct this by, so I'm just copying and I'll put that down here. We can correct this by using rand range. So this will never generate an 11. Yeah. And we don't actually need the import statement down here, since we've already imported it once. Okay. So I covered a lot of different topics in that example exercise there. So any questions about that before we move on to doing some data analysis in Pandas? Okay, cool. So moving right along. So reading tabular data into data frames. Yes, so just to reiterate, by switching to rand range, we corrected the issue with the index. That rand int has in it. That would also work. So one of the participants has said that you could do an alternative solution, which I will put here, would be to do the length of bases -1. So this will also never generate an 11. So this will only ever go 0 to 10. So that's an alternative solution. So the key, remember, so Python is 0 indexed, and if you see an index out of error, that means that somehow you're off by 1 in your indexing code, and you'll need to kind of go back and figure out what's going on. Okay. Hold on just 1 second. Somebody has come to my door, so I am going to pause. Okay, so we're recording again. Share my screen. Okay. Okay, so in this episode, we're going to start in on using the Pandas library. So the Pandas library is probably the go-to library for doing tabular data analysis in Python. And I'm going to show you how to load some CSV files into a data frame for analysis. Okay. So again, we're going to use Pandas. So that's a library for doing statistics on tabular data. So tabular data just means like rows and columns. So typically, the columns are going to represent features or variables in our data, and rows are going to represent observations of our data. And so that's what I mean by tabular data. So it's two-dimensional data. Okay, so the first thing we're going to do is we're going to import the Pandas library. So the canonical import statement is to import Pandas as PD. And then we're going to read in some data. So so we can do PD and then hit tab. And Pandas is a pretty big library, so sometimes it takes a little bit for all of the information about what's in Pandas to load. But there is a read CSV function, which is quite complex. There's a lot of options in this read CSV function. But the first thing we need to do is just pass in a file path to our data file that we want to load. So the data file that we're going to load lives in is slightly different. The path is slightly different than what's in the notes here. So if you look at relative to our current location in the notebooks directory, so in the notebooks directory, the data lives in the data directory. So from the notebooks directory, we need to go up to the parent directory. And if you remember from our shell lesson, that means we use the ... to reference the parent directory. And then we go down into the data directory. And then once we're in the data directory, we can type the name of the file that we want. In this case, Scapminder GDP Oceanic. CSV. And we will assign this to the data frame, or to a variable called df. Okay. And once we've done that, now we can look at, we can display this data frame a little bit and see what it looks like. So in this case, we see it has 2 rows and has quite a few columns. The country is in the first column, and then other columns seem to be GDP, something called GDP per capita, and then in different years, like 1952, 1957, and so forth. GDP per capita means that GDP is gross domestic product. So it's like everything that was the value of everything produced in that country in that year. So in 1952, per capita means divided by the number of people. So it's like the amount of stuff produced per person in a country in a given year. And okay, so let me take a look at the chat. Okay. Okay. So file not found. So many of you might have encountered a file not found error. If if we did something like this, we would get a file not found error. So this is the type of error that you get when the read CSV function cannot find the CSV file at this path on your computer. And the reason it can't find this is that the path that I have put in here would be expecting there to be a data directory in the notebooks directory and then a CSV file in that directory, but there isn't a data directory here at all. And that's because from the notebooks directory, we need to go up to the parent directory and then down into data, down into the data directory. Okay. This is a very common error, these file not found errors. And it's one of the tricky things about getting started with data analysis is often just making sure that you can read in your data files. Okay, given that the data in our data frame looks like it's kind of indexed by country, what this means is that each country, once you know the country name, that uniquely determines the values in the rest of the columns. So instead of 0 and 1, it would probably be better to use Australia and New Zealand as the indexes for the rows. And so we can do that by using, there is an index column option in the read CSV function, and we can pass in the name of the column that we want to use as the index column. And so now we have Australia and New Zealand as the row indices. And this is going to be useful when we start talking about indexing and subsetting on of data frames, because we can talk about indexing using countries instead of indexing using integers. You can find out some more information about data frames. There's an info function that you can call, and it gives you information about a data frame. It tells you like what is the data type in each column. So these are all floating point numbers. It tells you how many not missing values are there. So each column only has 2 values. So the fact that these are 2s all the way down means that there's no missing data. Tells you how much memory is used by the data frame. What else? So there is a columns variable associated with the data frame, and this just gives you information about the columns, so you can get access to the column names in this way. You can transpose, which means swapping rows for columns or vice versa, with transpose. So here, instead of having rows Australia and New Zealand, we have rows indexed by a year, basically, and then the columns are for individual countries. If you want some summary statistics, you can do describe. So this will do means, standard deviations, and different quantiles like min, max, and 25, 50%, and 75% quantiles. So your basic kind of summary statistics. Okay. So there's some questions in here. So can I use an Excel or a text file in Python? Yes, absolutely. So if you have your data stored in an Excel file, actually Pandas has a read Excel file, or read Excel function, which allows you to directly read in an Excel spreadsheet and get it into a data frame. So yes, you can also read Excel files directly. So reading text files is a bit more problematic because it depends on how the text file is structured as to whether or not you would be able to read it in. So if the text file was structured, then you would probably be able to read it in using one of these read functions. But you would need to know something about the structure of the data file. Okay. Okay. And so there's some questions about sharing the data. So this data is already available. It's in this, it's in the directory, in the data directory already. So as long as you remember to do the path to the data correctly. So relative to the notes, you need to add .. / in front. You should be able to get access to this data and use it directly, in just as I'm doing now. Okay. So we have some more exercises. So I would like you to take 5 minutes and look through these exercises. In particular, the first two, so reading other data. So make sure that you can read the other data files. So there are the same data for different continents in here, and then a data file that has the whole world. Practice changing the file path to make sure you understand how to read in these CSV files into data frames. And then that's the most important of these exercises. So if you can't load it, it must mean that you're either getting an error like this, some kind of file not found error. Yeah. So the file not found error means that you're not correctly typing the path from the directory containing the notebook, which is in this notebooks directory, to the file containing the data. Right? So to get to the directory that holds the CSV files from the directory where our notebook lives, we need to go up one level to the introduction to Python directory. So that's the parent directory. So that's what's represented by the ... followed by a slash. And then from this directory, we go into the data directory. And then inside the data directory, we have the CSV files. And if you've made a typo in the file name, you will also get the same file not found there. So make sure you don't have any typos in the name. But that data should be there. So can everybody see this introduction to Python directory? Yeah, okay. So I mean, if you click on this file, you'll go all the way back to the root of the file system for your compute instance, and you should be able to see introduction to Python, and then in there is the notebooks directory and the data directory. So, okay. If you're running in the cloud, if you're trying to run locally, then I can't help you because you have to install all the software and everything yourself. Okay, so go ahead and take a few minutes, work on these exercises. I'll just set a timer for 3 minutes, and then we'll pick up in a couple of minutes. Okay. All right, so I want to talk a little bit about, I can see people are still having trouble getting the data loaded. And so let's try something else. So it's possible that many of you have created this notebook somewhere else, somewhere different than where I created it. So if you want to find out where you created your notebook and you're not entirely sure, then what you can do is you can use the bash magic command and just type pwd. And so this will tell you where the notebook file that you created lives. In my case, it's in /home/jovian/introduction to Python. So here's introduction to Python /notebooks, and then here's the file. Yeah. Now, in order to get the data file to read properly, we need to pass in the path okay. Sorry, thank you for letting me know I was not sharing my screen. So we can use this bash command, pwd, and this is going to give us the path to where my notebook file lives. Yep. And so it is in home/home/jovian, which is just the user home inside of this compute instance, introduction to Python, notebooks. So this is where I saved my notebook file at the very start of today's workshop. You may have saved your notebook somewhere else. And if that's true, then this will look different. And that's okay. But it might look different. If you saved it in in this root directory, then it might just say /home/Jovian. If you saved it in Introduction to Python, it would show up here as a file down here somewhere, and it would have /home/Jovian/Introduction to Python. Now, the path that we pass in here to load the data needs to be the path to the data file from this directory. So that's why from the notebooks directory, we go ... to go up one layer in the file system hierarchy, which corresponds to, in this case, the Introduction to Python, then down into the data directory, and then we have the Gapminder CSV file. So you have to, whenever you are, that's why I spent so much time in the shell lesson talking about the concept of absolute paths versus relative paths. If you wanted to path, instead of a relative path, you could also do the following. Let's do, maybe this would work. So this absolute path should work for everybody. So if we do the absolute path from /home/Jovian /introduction to Python, so this should work for everybody. So here I'm passing in the absolute path from the root of the whole file system in our compute environment down to the data file. So no matter where you saved your notebook file, this absolute path should work. But this concept of absolute and relative paths is very, very important because it is what will allow you to load your data properly and efficiently. So you can always use an absolute path, but the problem with absolute paths is that depending on how deep your file system hierarchy is, the absolute path could be incredibly long versus the relative path is usually much shorter. Okay, cool. So if you're uncertain about absolute versus relative paths, you can check out the shell workshop from a few weeks ago. And there's a whole episode discussing the differences between absolute and relative paths. Okay. Okay. Okay, so let's just, let's give another example. So let's load, okay. So here I have loaded in the Gapminder GDP Americas CSV and used the country as the index column. Okay. And if we wanted to display the summary statistics, we could do describe. To get the summary statistics. Okay. If we wanted to look at the first few rows, we could do Americas.head. So that will look at the first 5 rows. If we wanted to do the first 8 rows, we could put an 8 in there, and that would give us the first 8 rows. Similarly, we could do .tail to look at the last few rows. So if we wanted to do the last 3 rows, we could look at the last 3 rows. And if you recall back from our shell episode, again, we had head. There was a bash command called head and a bash command called tail. You're going to recognize some of the function names that we use on data frames because they derive from the same functionality in the bash in the bash world. Okay, so I'll just mention writing data. So we've been reading in CSVs, but in addition to read, there's also a bunch of functions that will write your data frame out to other file formats. So you can write to CSV, you can write to Excel files, you can write out to all different kinds of things. Each of these has their own utility depending on your use cases. And the thing to know is that if you need to write out to a particular format, your data frame, there probably already exists a function for doing it. Okay. Questions about reading in data before we move on? Nope. Okay. So let's move right along to Pandas data frames. Okay, so we're going to cover the kind of bulk of the basic ideas behind using Pandas data frames in this episode. So a Pandas data frame is a collection of Pandas series. So a Pandas series is like a column of data with row indexes, and the column of data will have its own particular data type. It could be a string, could be integers, could be floating point, could be something else. And then a data frame is just a collection of these series that share the same row indices, which that basically makes a table. That's the way to think of it. So Pandas is built on top of NumPy, and it uses a lot of NumPy's underlying array manipulation operations to operate on tabular data. So, for example, just like so let's load in some data. So let me go back up here. I'm just going to copy my instead of Europe or instead of Americas, we're going to load Europe. Yeah, Minder GP. Let's see what the name of the file is. Europe. Okay. So let's look at the first few lines of Europe. Okay. So just like you might index into a matrix with your I row and j column coordinates, we can do the same thing with a data frame using ilog or ilog. So that's short for integer location. So now we use the square brackets because we're doing integer location indexing. So anytime we're doing indexing, it's going to be a square bracket. So we could do 0, 0. And that gives us the 0th row, 0th column entry. So that's 1600 roughly, which was the GDP per capita of Albania in 1952. Now, typically, we don't use, because we're not actually working with this kind of IJ index or integer-based indexing makes sense when you're talking about matrices or arrays, but it doesn't really make sense when you're talking about labeled data, like a data frame, where we have row labels and column labels. It's much more intuitive to refer to the rows and columns we want by their labels, not by their integer indices. So we do that by using the location or label-based indexing. And so here we might say, well, give me the value of Albania's GDP per capita in 1952. And so we get the same answer. Now, usually we don't just want like one particular value. We usually want an entire row or entire column worth of data, at least. So for example, if we wanted to do the all of the data for France, we can use the colon to stand in for all of the columns in this case. So we want all the data in the row whose label is France, but then all of the values in all the columns. And so that gives us a Pandas series object whose row indices are GDP per capita in 1952, and whose name is, the column name is France, basically. Alternatively, we could do, from the Europe data frame, we could select out an entire, so let me just put a little comment in here. So selects an entire row of data. And this will be selects an entire column of data. So to get an entire column of data, we will select all the rows, and then we pick like I don't know, GDP per cap. GDP per cap in 1967. So this gives me all the values for GDP per capita in 1967 for all the countries in Europe. So we could do, if we want multiple rows, but we can still use, we can use the labels to do multiple rows. So we could do something like Italy to Poland. And then, so these would be a subset of rows in all the columns. Or we could do a subset of the rows and a subset of the columns. So we could go GDP per cap from 1957 to 1987. So there's a subset of, and I'll just change it. So there. So I guess to sum up, you should prefer this location based indexing over integer locations in almost all cases. And you use this slice notation to select different rows and columns that you might want to use. So we can use these subset of data in further calculations. So for example, suppose we wanted to compute the max value the max value of GDP per capita from these countries, so Italy, Montenegro, Netherlands, Norway, and Poland in these years. So what this does, or what this has done is gone through for each column and picked out the max value. So of these countries, Norway is probably the wealthiest, maybe the Netherlands in some years, but probably Norway. And so I would guess that in each of these years, Norway might have been the wealthiest. And so actually, the above is the same as this. Oh, no. Oops. And in these years. Okay. So we can assign, sometimes we will assign subsets to their own variable just to make things a bit more legible. So if we assign this particular subset of data that we're interested in to some new variable like subset, we can do things like say subset greater than 10,000. Now, what this has done is it's gone through and for each data item in the table, it has run the comparison of is the value greater than 10,000 and return true if that's true and otherwise false. And so you can see here that Montenegro, for example, had low values of GDP per capita. And so you see lots of false all the way through until 1982. Poland has had low GDP per capita throughout this entire time period. And so it's false all the way across. Norway and the Netherlands have been were relatively wealthy. And so they've had true all the way across, for example. What if we want to select values where a condition is true and then fill in missing values everywhere else? So that's called masking. And we can do that really easily. So we could say subset. Let me just give it an example. So we'll call this some condition, subset greater than 10,000. And then we can say the subset, and then we can use the square brackets to do indexing, and we can use the condition to do the index. And so what this does is it goes through, and anywhere where the condition is true, you get, instead of true, you get the actual value from the data table or the data frame. And where the condition is false, you just get missing data. So this is really useful. So this can be useful, for example, if you want to filter out data before computing things like descriptive statistics. So now, when we filter out the data using this condition to mask out values, then when we do the descriptive statistics, these descriptive statistics are computed using only the values that are not masked out. So here it just computes using these 2 values. Here it uses these 3 values. And then by 1987, these 4 values will be used in computing these descriptive statistics. So that's a fairly handy technique. Okay. Now, time for something a bit tricky. So we're going to talk about this group by calculation. So split, apply, combine idea. Whenever you're attacking a data analysis problem, it's very useful to think in terms of a sequence of calculations called split, apply, combine. And the idea is that you want to take your original data set, which could be very large, and you want to think about how can I split it into chunks, apply some calculation to each chunk, and then combine the results to get usually a smaller data frame. And this is really a really useful way to think about structuring your data analysis, because as you start working with larger amounts of data, once you have split your data into chunks, you can often process each of the chunks in parallel using multiple cores or even multiple nodes in a compute cluster, depending on how big your data is. So thinking in terms of split, apply, combine is a good mental model or a good way to think when doing data analysis. Okay, so let's give an example of this. So let's take our Europe data. And let's calculate the mean. Okay. So what this has done is it's computed the average GDP per capita across all the countries in Europe for each year in the data table. So that's for each column in the data. Okay. Now, let's ask let's look at this condition. So what this has done is for each country and each year in the data, it's asked, is the value of GDP per capita for that country greater than the average value for that year? So let's, I'm going to add a few more rows and let's look at this. Europe. And Europe B. Okay. So I'm going to just pick some examples to show you how this calculation is going. So what this what this condition here is doing is it's taking, so for example, the GDP per capita for Albania in 1952, which was 1,601, and asking, is 1,601 greater than the mean across all of the European countries for GDP per capita in 1952? So that's in the same column. Is 1,600 greater than 5,661? Well, no, false. So that's why this is false. If we go over, let's look at Belgium in 1967. So Belgium in 1967, the GDP per capita was 13,149. So let's compare 13,149 to the mean of GDP per capita in 1967. So that's the average across all the values in this column. So that is 10,143. So since 13,149 is greater than 10,143, should be true. True. And so on and so forth. So that's what's going on. That's what this one line of code is doing, and it's creating this mask, this condition. Now, So now what we can do is we can do a further calculation on this. So let's get this out of the way, and we will call this is richer than average. So I'm going to assign this this data frame, this Boolean mask data frame, to a variable called is richer than average. And now what I'm going to do is I'm going to say is richer than average, and we can compute the mean of this. But what we want is the mean not across the rows, but across the columns. Okay. So what this has done is now for each country, we have said what is the percentage of the time that this country is richer than average. So, for example, let's look at Austria. So Austria has true for every column. So that means every year the GDP per capita in Austria was greater than the European average in that year. So that's like, so when we take the mean of these values here, so that's like the mean of these Booleans, true and falses, which get mapped into zeros for false and 1 for true, then that mean will turn into, if it's all true, it's like adding up, 1 for each of these trues and then dividing by the number of columns. So that gives you a 1 overall. If you look at a country like Greece, that comes out to be 0.33. So 33% of the time, or a third of the time, Greece was richer than average, or wealthier than the European average in that year. So what we've done is we found a way to kind of group countries. So countries that are relatively poor are going to have a score of 0, according to this metric. Countries that are relatively rich are going to have a score of 1, and then other countries are going to fall in between into different groups. So now what we can do is we can do things like we can take our European data and we can group by, and let's call this our wealth score. We can group by the wealth score, and then we can compute the mean. And now what we have a new data frame, which has grouped the countries into these bins. So depending on their wealth score. So we've got a bin of poor countries who have a wealth score of 0, of rich countries have a wealth score of 1, and for intermediate countries that have either 1/3 or 1/2. And then these values represent the average GDP per capita in 1952 across all countries whose wealth score was 0. So this is a way of doing this split, apply, combine. So the splitting is the grouping. So we did this somewhat involved calculation to come up with this wealth score, which then we use the wealth score to do the grouping, the splitting of the rows into different groups, into different bins. And then the apply is the mean operation. So then once we have the rows grouped into different bins, we apply the mean operation within the bin, and then we combine the results back into a single data. So it might take some deep thought on your part, but it is often the case that your the calculation that you want to perform on your data can be done with this split apply combine or this group by apply paradigm. So this is just a particular example of that. Okay. So that was a bit involved, more involved than some of the other stuff that we've been doing so far. So let's take a few minutes and have a look at these exercises. And also now might be a good time for just a short break, so maybe a 5-minute break, and then we'll come and we'll push through to the end of the workshop today. So we'll come back at, say, 10 after, so just in a few minutes, and then we'll push through to the end of the day. Okay, so we're back, and that will be our last break before we end today. So the next thing that I want to talk about so I guess, so real quick, does anybody have any questions about those exercises? Did somebody come across an exercise that they were a bit stuck on and would like me to work through? Or should we just move on to the next section on plotting? Okay, so we'll just go ahead and move on to the next section on plotting. Okay. So plotting. So how can I plot my data? So that's what we're going to work on in this. We're just going to scratch the surface. Visualization is obviously a huge topic itself. And we're just going to scratch the surface. So matplotlib is the most widely used plotting library in Python. So we can take a look at matplotlib. So here's the homepage for matplotlib. They've got a handy cheat sheet here that you can download, as well as a huge amount of examples. So there's some examples, and if you want code to generate certain plots, you kind of just come to this examples and just kind of scroll through here until you find the plot that you want to reproduce. And let's pick one that looks kind of interesting. Let's go with this one. Okay. And so here they have a lot of discussion of the plot and how to kind of make the plot work. And you could copy this code, paste it in the notebook, and it would run without should run without issue. So that's how I would whenever I need to get started on a plot, I come to the matplotlib examples, go through, find an example that's kind of close to what I want to do, copy the code, paste it into the notebook, run the code, see that it works, and then try to go through and figure out how to change it to work with my data. So let's see some kind of simpler examples. Okay. So first we need to import the library. So we import matplotlib.pyplot as plot. And someone is drawing on my screen. And let me see if I can figure out how to get rid of it. There we go. Okay, done. Or not. Okay. So we need to import matplotlib.pyplot as plt plot. That's just the canonical way of importing matplotlib. Then if we wanted to manually make a plot, we could do, we could create a list of time values, one, and a list of, I don't know, position values. And then we could just make a simple plot, plot.plot. Time and position. And so that's a simple plot. If we wanted to add an X label, we could do that. If we wanted to add a Y label, do that. So position kilometers, time in seconds. And if we wanted to add a title, we could add a title. My first plot. Right. Okay, things like this. Now, when we're plotting with data frames, there's some handy kind of built-in features to plot data frames. So so we're going to read in our data from forgotten how these files are named again. Okay. Now what we can do is, so now we have our data frame. But I actually want to change the, I'm going to make some changes to this data frame. But first, let's just plot it. So there's a nice method called .plot. And you plot it, and you get, in this case, we get a graph or a plot. But it's not all the plot that we want to get. Because what has happened is that by default, we get one line plot per column. Yep. So here we have our little legend that's mapping colors to individual columns, but that's not what we want, really, because remember, the data is organized where each country is really kind of what is indexing the data. So we have each row, and then we have all these columns. What we really want is to plot the GDP per capita over time for each country. But remember how I said you could swap rows and columns with transpose? So if we do transpose.plot, this is a little better, but this is a bit messy. And the reason that's a bit messy is because our column names are complicated GDP per capita 1952, and not just like 1952, like the year. So we can fix that with a little bit of manipulation. So for example, if we do, remember we looked at the columns data, or the columns variable for a data frame. So if we want to, so suppose that we want to apply some transformation to each of the strings here. So these are individual strings in this kind of list-like object. So we can do that. There is a .string, which allows us to apply string methods to each individual entry in this index. And there's a string method called strip. And this strip method allows you to remove text from a string. So in particular, we are going to remove the GDP per cap. So then what we get back is these cleaned up strings. But this is almost right, because actually then what we want to do is cast the data from a string to an integer type. And so now we get integers. So then what we want to do is to kind of replace if we call this years, and then just to make this a little bit easier to read, I like to do something. You'll often see complicated data transforms stored like this in Python. So then what we can do is replace the columns with the years. And now when we can redo the plot, and now we have this nicely formatted access here. So this is a bit of an example of the kind of like data cleaning that is fairly typical when you get kind of messy raw data that you need to manipulate a little bit before you do some analysis. So this is kind of a bit of a contrived example of that. In practice, what I would probably do is I would do this code once, and then I would write out, I would store rewrite the CSV files so that they're cleaned up, so that this code only has to be run once as like a cleaning step, and then it's not done again. But really, this is just cleaning up this plot. Okay. If we wanted to just plot one country, we could do from Oceania.transpose. We could select out all the rows for the column called New Zealand. And then we could plot it. So that's an example of that. So there's many kinds of plots that you can do. So by default, you get just line plots, but you could do, there's a kind keyword, which you can do for bar chart. all the plots have a default styling. So if, for example, you would want to change the style, there's a plotting package in R, which is very popular aesthetically, like the color schemes and everything are very popular. So you could change your style to ggplot, and then all your plots from here on out would look like have that kind of color styling. What are some other examples here? So so here we've been using the data frame methods to plot. So let's see another example of that. So we should be able to do dot there's a way to do a scatter. So I think we can do a scatter plot of the Australia GDP per capita versus New Zealand GDP per capita like this. So you can use, if you select out the data on your own, or like in this example here where we select out Australia, we can use the plot, the matplotlib plot method directly to plot data instead of using the built-in plot with pandas, but I prefer to use the built-in plot. So there's some more examples here of adding legends and things. We just did the scatter plot example. Okay. All right, so it's about 4:30. So we can go through some more plotting examples, or let's see what's next. Probably best to just end on some more plotting examples. Okay. All right, let's give you some opportunities to do some plotting exercises. So take a look at these exercises. And I will also pick a couple of exercises to work through. And then I think we'll probably wrap it up. I'll leave some time for Q&A, and then we'll wrap it up. Okay. So one of the exercises actually asks you to look at this data for the whole world. So there's this gapminder all CSV file. And this is a good example to show how you can have multiple columns index a data set. So here, if we do the same kind of data loading code from before, we're indexing by country. But actually, now we have two columns that index the rows. We have country and continent. And so we could do, or we could actually do it the other way around, continent and then country. So continent and then country. So you can actually list multiple columns. And now if you look at it, we have a data set where we can do location based on, say, we can grab all the countries in Africa in one go. And now we can get a data frame that looks like, or get a data frame for all the countries in Africa in one go. So this is a really good way. So thinking clearly about how to index your data is really important. And so this is an example of how in Pandas you can use multiple columns in your raw data to index your data frame. So now what I'm going to do is we're going to create a plot of the correlation between GDP per capita and life expectancy. So we have more data than just GDP per capita. We also have population data for these countries, and then also data on life expectancy. So how long are people likely to live? So what we can do now is we can do world, and we can plot, and we can do a scatter plot. And for our column, we can look at the GDP per capita in 2007 and life expectancy in 2007. So let's just look at this scatter plot. Okay. So what this is saying is that the higher levels of GDP, and you have higher life expectancy. But so as countries get wealthier, the population tends to live longer. But you can see that it's not like a linear relationship, because there's a huge difference in life expectancy when you go from being incredibly poor, so having extremely low values, up to say 10,000. So there's a big spike, jump up in life expectancy when you go from having basically nothing to being relatively poor, but then it's kind of flat. So adding, even increasing your GDP per capita by a factor of 5, only increases your life expectancy by, just looking at it, maybe like 5 years or something like that on average, something like this. So we can change this plot a little bit by adjusting the size of the markers, so the size of the dots, by population That's crazy. What's happened here? Well, the reason that's happened here is that the population are in millions of people. So we need to rescale them to avoid this. And the way that we can do that is by saying world location and then dividing that by 1 million. And so that changes everything. So that would be another example of a kind of a plot that you could do. If you're wondering about the code, so today's code, so I'm going to save this notebook and then I will upload it to the GitHub repository so that my notes will always be there. In fact, I'll do that now. So if I go to Introduction to Python and Notebooks, and I'm going to right click and then I can do rename. I'm going to call this sandbox. And then I'll save it. And then I can do file and download. And this will download this notebook on. This is downloading it from the cloud computing resource down to my computer. And then I will upload this to GitHub when we're done. And then that will give you all of my code that I wrote today in this notebook as a reference to go along with whatever your own code that you have. And of course, you can download this notebook yourself if you want. Remember, it's file and then download. We'll download that notebook for you. Okay. Okay. Well, I don't know about you, but it has been a long afternoon. So let me just talk through the rest of the notes so that you maybe know some other things to look at. So I tried to just give you a bit of an overview into Python, give you some examples of pandas and things, and some basic plotting, just enough to try to get you over that initial entry barrier so that you can kind of pursue more in your own time. So the things that of the remaining episodes that we didn't cover, so for loops, conditionals, and looping over data sets, I had hoped to get to today, but there's not going to be time to cover any of those topics, unfortunately. And then writing functions is another important one. If you come along to the advanced workshops that I'll be having in the spring, we will kind of just jump right into doing that. So we'll be doing scikit-learn and PyTorch, and we'll be writing for loops and functions, lots of functions and things. So it would be good to have a look through some of that material, at least familiarize yourself with it if you intend to take the advanced workshops, where we'll focus more on applications in the spring. So now let's just have some time for Q&A. So question in the chat. So what is the best way to grow someone's data science portfolio? So this is a great question. my recommendation would be to use a something like Kaggle. So let me share my screen again. So if I was just getting started today with my journey towards learning more about data science and machine learning, and I was very focused on wanting to develop skills to apply these tools to solve new problems, I would start by creating an account on Kaggle, or there's another one called Zend. Zindy. So either Kaggle, and then with Kaggle, you can both get practice in solving or in applying these techniques to solve novel problems, but you can also win awards and earn points and kind of build up a reputation for yourself as a Kaggler. And that is actually quite useful in building up a portfolio of work, because you can then take your work that you've done on Kaggle and share it on GitHub. So Zindy is a Kaggle-like platform for competition, but it's specifically focused on African data sets. And I find that they have some really interesting data sets that don't get nearly as much attention as Kaggle. So there's a lot more scope for quickly doing new and interesting things on these data sets on Zindy than you might find on Kaggle, where you'll already find a notebook on Kaggle for every possible combination of machine learning or deep learning application that you might want on particular competition, because there are so many people who are doing Kaggle. But so get on one of these competition websites, practice your modeling and your coding skills, and then go to GitHub and create an account on GitHub and start sharing your work on GitHub. So that is your GitHub profile is kind of become your CV in a way, if you're doing data science or machine learning. So you can use your code that you've posted on GitHub as an example of the work that you can do. And so those would be the two things that I would do. Focus on developing your machine learning or data science skills by participating in these competitions on Kaggle or Zindy or another competition platform. And then share your work on GitHub. And next week, we're going to focus on Git and GitHub. And you will learn, if you come next week, you'll learn the basic mechanics of how to use GitHub to both keep track of all the different versions of your code and your project files, but also how to share things on GitHub. So if you want kind of a brief introduction to how to do that, you can definitely come along next week. Any other questions? Let me share those links in the chat in case you missed them. So there's the link for Kaggle, the link for Zindy, and the link for GitHub. Any other questions about Python programming? Let's see. Here's another good resource. Just a second, I'm gonna get it up on Google. Okay, so I didn't go to the Pandas Pandas webpage earlier, but I meant to. So if you really want to learn how to use Pandas, then there's a book called Python for Data Analysis by Wes McKinney, and there's a link to it on the Pandas website. So I'll put that in the chat as well. So the link there takes you to Amazon. If you are at KAUST, then most of these O'Reilly books, including the Python for Data Analysis, are available through University Library. And if you're outside of KAUST and at a university somewhere in Saudi Arabia, you may also have access to them as well through your university library. Otherwise, you can search about for them online if you want. But that's a great resource for learning in detail how to program in Pandas. So everything I know about Pandas, I learned by going through that book kind of from cover to cover. It took me several months when I was in grad school, and with the first edition of that book, when it came out, I went through it cover to cover, and it took me several months when I was in grad school and had time for such things. But it's a great reference resource. The second edition, you definitely want the second edition because there's been quite a lot of changes, and the second edition came out, I think, last year, so it's still pretty current. So other than that, I think I'm done. I don't have anything else to say unless someone has questions. I'll hang around for a few minutes to see if anybody has questions, but otherwise, thank you so much for coming. And like I said, next week we'll be talking about Git and GitHub, and then the following week we'll wrap up the workshop series by looking at SQL, which is a structured query language for extracting data from databases. And we'll be using JupyterLab in next week and in the week when we talk about SQL. So thank you very much for coming and staying with me for this afternoon. And like I said, I'll hang around for a few more minutes or until everybody leaves if there are questions. And I will send around the link for the video on YouTube sometime tomorrow after I've had a chance to edit the video and upload it. Okay, any last minute questions? Doesn't seem like it. Okay, well, thank you very much. I'll see you next week.